Hello everyone, hope you've all been well. Today I'm going to be helping you through some calculus problems during this 1 hour. Welcome to OneClass. My name is Marlyn. I'm the second year student at the University of Waterloo. I'm studying chemical physics with a minor in math, and we're just going to run through these calculus problems today. Okay, so first off we want to find an equation of a sphere with center 2, 6, 4, and radius 5. And so in order to do this, we need to remember the general equation of a sphere, which is x minus xo squared plus y minus yo squared plus z minus zo squared is equal to r squared. And xo will be the center of the sphere in x coordinates. So in this case, it's going to be 2. Yo is the center of the sphere in y coordinates, so it's -6 here. And zo is going to be the center of the sphere in our z-axis, and that's going to be 4. And our radius, as we know, is going to be 5. So I'm going to just plug that all in here. We have x minus 2 squared plus y minus 6 is +6, so y plus 6 squared plus z minus 4 squared is equal to 5 squared, and that's the same thing as 25, of course. Okay, and next we're going to describe its intersection with each of the coordinate planes. And so let's think of our xy plane first. And in our xy plane, z is equal to 0. So we're just going to plug that right back in here. And we get x minus 2 squared plus y plus 6 squared plus 0 minus 4 squared is equal to 25. And this -4 squared is 16, and I'm just going to move it here to the other side to become -16. And this is, of course, equal to 9, which is the same thing as 3 squared. And so we get x minus 2 squared plus y plus 6 squared is equal to 3 squared. So this is going to be a circle centered at 2, -6 with a radius of 3. Okay, next up we're going to do our next coordinate plane. And that is going to be the YZ plane. And in this plane, of course, the x is equal to 0. So whatever is not in it. So y and z, which means x is equal to 0. And of course, we just plug that right back in. So 0 minus 2 squared plus y plus 6 squared plus z minus 4 squared is equal to 25. And -2 squared we know is 4, and I'm just going to bring that right on over to get y plus 6 squared plus z minus 4 squared is equal to 25 minus 4, and that's going to be 21. So this is a circle centered at 0, because x is 0, -6, 4, with a radius of roots 21, because remember this is equal to r squared. And last but not least, we are going to do the xz plane. This one's going to get a little bit weird, but when you actually see it, which you will soon, you'll understand it a little bit more. And so in the xz plane, y is equal to 0. And so again, just plug that right back in. So x minus 2 squared plus 0 plus 6 squared plus z minus 4 squared is equal to 25. This 6 squared is 36. Move that right on over. And we get x minus 2 squared plus z minus 4 squared is equal to 25 minus 36. And that will give us x minus 2 squared plus z minus 4 squared is equal to negative 11. Now this one is a bit harder to see, but we already know that we will have a circle centered at 2, 0, 4. The radius looks confusing because it's a negative and that doesn't make sense, but it will be a radius of root 11. So let's go on over to a 3D graphing calculator to see what that actually looks like. It's always great to have a visual for your math problems, and GeoGebra provides that. And so let's just plug in our equation. So x minus 2 squared plus y plus 6 squared plus z minus 4 squared. And let's not forget about the radius. And so you start to see that it's a sphere, as we described, and you can just rotate it around. And we see it interacts with the xy plane indeed, the yz plane, and the xz plane. And this is just what it looks like. So that would be the circle that we see, that we described. And that's it. Okay, on to our next question. Okay, so we want to change from rectangular to spherical coordinates. These points. So rectangular is the same as Cartesian. And we have 0, -2, 0, and -1, 1, negative root 2. And so we need to remember how to go from Cartesian, which is x, y, and z, into spherical. Which is rho, theta, and phi. And we usually do this when we're calculating the surface area of a sphere or doing anything in calculus related to spheres. It's easier to just use spherical coordinates. And so we need to remember that our rho would be equal to the root of x squared plus y squared plus z squared. Our theta is equal to the inverse cos of x over rho sine phi, and phi is equal to inverse cos of z over p. Okay, and so now when we do a, let's just write that here for you. Let's square root theta And phi is the inverse cos of z over p. Just so we can clear this down here. And let's start with a, of course. So our rho would be equal to the root of 0 squared plus negative 2 squared plus 0 squared. Negative 2 squared is just 4, so that's root 4, which means that this is equal to 2. Next, let's calculate phi, and that's going to be the inverse cos of our z, so 0 over rho, which is going to be 2. And because of the fact that y is less than 0, which we have to take into account, we will get that this is equal to 3 pi over 4. And that's the theta is equal to the inverse cos of x over rho sine phi. And that would just be phi. So x is 0 over 2 sine 3 pi over 4. And that's going to be equal to, sorry, I think I made an error here. This here is pi over 2. That's cos inverse of 0 is pi over 2. And this here is going to be 3 pi over 2. And this is due to the fact that y is less than 0. And so 0, negative 2, 0 becomes 2 pi over 2, 3 pi over 2. Sorry, I wrote them wrong. Three pi over 2 because you put theta first, and then phi over 2 because pi over 2 because phi is last. And then next we're going to be calculating b. So it's the same calculations, just different numbers. And so this is equal to negative 1 squared plus 1 squared plus negative root 2 squared. And this is 1 plus 1 plus 2. So that is going to be root 4. So again, it's going to be equal to 2. Next up, we're going to have phi, and that's going to be the inverse cos of negative root 2 over 2. And this will give us 3 pi over 4. And theta is going to be the inverse cos of negative 1 over 2 sine 3 pi over 4. And this, because of the fact that y is greater than 0, will also give us 3 pi over 4. So the coordinates negative 1, 1, negative square root 2 in Cartesian/rectangular coordinates will become the coordinates 2, 3 pi over 4, 3 pi over 4, and spherical coordinates. So it's the exact same point, you just moved it to a different coordinate system. And we'll see things like this using different methodology in linear algebra. Okay. Okay, so again, we're going to be doing a conversion, and we are going to be converting the point 3, negative 3, 7 from rectangular/Cartesian to cylindrical coordinates. And so that's going to be r, theta, z in cylindrical coordinates. Okay, so again, we need to remember how to convert from Cartesian coordinates to cylindrical coordinates, and that is going to give us r is equal to the root of x squared plus y squared. Theta is equal to the inverse tan of y over x, and z is simply equal to z. And so we're just going to plug in the values that we have, and we get r is equal to the root of 3 squared plus 3 squared, which is root 18. And that is going to give us 3 root 2, because this is simply 9 times 2, and this becomes that 3. Theta is going to be the inverse tan of negative 3 over 3, and that is going to be inverse tan negative 1, and that is going to give us negative pi over 4. And lastly, z is just equal to the z that we have there, so it's 7. That means that our 3, negative 3, 7 will become 3 root 2, negative pi over 4, 7. And we usually do this conversion when we're, for example, calculating surface area of a cylinder. So when we're using objects that look like cylinders, like wires in physics, and so on and so forth. So, okay, this one is a bit longer. So the answer is given in 2D, and it is correct, but I'm going to give you the 3D answer. And we are going to interpret it in 2 ways. And so we have the physical approach, and we have the geometrical approach. Okay, so for the physical approach, let's imagine a curve. And it starts at t is equal to a and ends at t is equal to b. Let's imagine a small segment of that curve here. And let's call this delta L. And delta L will start at t and end at t plus delta t. And along this curve, you will travel at the speed of so the speed at which this curve would be traced out would be dl over dt. And that should be equal to the speed, of course, which is the same thing as the magnitude of the first derivative of the path. Hence, it follows that, just by bringing this delta t over here, delta L is equal to times delta t. And so, since we're going to be adding up these many small segments in order to get the entire thing, the entire length would be equal to the limit as delta t approaches 0, because we want to add infinitesimal segments together, because they're not straight as this tiny path is. So we're going to add very, very small straight pieces together in order to form this curve. And that's where we get into integrals. And so the limit of this, and that is the same thing as integrating from t is equal to a to t is equal to b, the speed dt, because of this. And that's our final answer. If we want to use the geometrical approach, it will lead to the exact same result. And so imagine a curve. And now let's approximate it by using a secant line, just like we did in graphs when we were first introduced to the concept of tangents, right before derivatives, right before integrals. And let's call this delta L, of course. Starts at t, ends at delta t. Entire path ends at t is equal to b. Entire path starts at t is equal to a. And so we can call this point x, y, z, and call this point x plus delta x, that small change in x, y plus delta y, and z plus delta z. And so if these spatial coordinates depend on the time, then we can use Pythagoras Theorem to get the equation delta L squared is equal to the root of delta x, is equal to simply delta x squared plus change in y squared plus change in z squared. And we're going to add, which is the same thing as the root, we're just going to rewrite it as delta y over delta t squared plus change in z over change in time squared, all multiplied by the change in time. And so since we're going to add up these small segments, we're going to get L is equal to the limit as delta t approaches 0, similar to before, of the addition of what we have here. And this will too become an integral. A to b of the same thing. The t instead of the change in t now. And finally, so let's just erase what we have up here. So this, what is inside of the square root is the exact same thing as the square root of r prime t dot r prime t dt. So this is going to be the same thing as from a to b dt. And so this is the same answer that we had before. And so our final answer becomes that in 2D, L is equal to the integral from a to b of root 1 plus the derivative of the function squared over dx. In 3D, if we're using our time as what's the spatial coordinates are changing according to, it becomes the speed. dt. And this is in 3D. And that's it. And so if we want to do a mini example, and we're going to be using 3D, let's just rewrite this. Let's take r is equal to r cos t, r sin t, t between 0 less than or equal to 2 to 2 pi. This, when you draw it out, will become a circle going counterclockwise. And so let's first find the derivative. So r prime t is equal to, first you take the derivative of r cos t, and that becomes negative r sine t. This becomes r cos t, and this becomes 1. Next, we find the magnitude of it. So this is going to be the magnitude of r squared sine squared t plus r squared cos squared t plus 1 squared. This is the same thing as r squared into sine squared t plus cos squared t plus 1. We know that this is an identity of 1. So this is just equal to the root of r squared plus 1. And next we just plug it into our integral to find the length of this line, which is the circumference of a circle of radius r. And this will become, so our a will become 0 and our b is 2 pi. So from 0 to 2 pi of root r squared plus 1 dt. This doesn't involve any t variable, so we're just going to pull it right out of the integral to become root r squared plus 1, 0 to 2 pi dt. This simply becomes t from 0 to 2 pi, and this is equal to 2 pi. So our final answer becomes 2 pi root r squared plus 1. And that's just how you do it. If you got whatever r, find the derivative, find the magnitude, plug it into what you have. If it does have a t variable, you will have to deal with it. If it's just a constant, pull it out and calculate the integral. And that's it. Okay, on to our next question. We're going to be looking for the derivative of, so we want dy over dx if y is equal to b to the power of x. So we're just going to rewrite this as e ln bx, because we know e to the power of ln a is equal to a. And according to our logarithm rules and properties, we know ln b to the power of x is equal to x ln b. So this is e to the x ln b. And next we're actually going to use the chain rule in order to find this. So we're going to write this as e to the u, and of course u is equal to x ln b. And so dy over dx is equal to dy over du by du over dx. So the derivative of e to the power of u in respect to u is of course just e to the power of u by the derivative of this with respect to x, which is just going to be equal to ln b. So ln b. And so if you plug e to the u back in, you get e to the power of x ln b, which is b to the power of x. So we're just going to write it in that form. And this will be our final answer. Okay, next we're going to be using the arc length equations that we found in the previous example. But now we're going to be using the 2D version because we have y and x only, so there's no need to include z. And so our 2D equation looks like L is equal to the integral from a to b of root 1 plus the derivative of fx squared dx. So first we're going to find if f of x is equal to y, and this is x4 over 8 plus x squared over 4. Its derivative, just going to be using the exponent rule, so that becomes 4x cubed over 8 plus 2x over 4. And I'm just going to write that exponent rule for you. Is just equal to ax a minus 1. Okay, and so we're just going to simplify this, and this becomes x cubed plus x over 2. 4 over 8 and 2 over 4. And so now we're just going to plug, we're just going to plug that right back in. And we know that our endpoints are 1 and 2. So this is going to become the integral from 1 to 2 of root 1 plus x cubed plus x over 2 squared dx. Now let's simplify that further. Of root 1 plus x to the power 6 plus 2x to the power 4 plus x squared over 4 dx. And again, simplify it further, and it becomes 4 plus x to the power 6 plus 2x to the power 4 plus x squared all over 4. And we're going to be taking the square root dx. We can pull out the 1 over 4 out of the square root, and that becomes 1 over 2, and then we're just going to pull it out of the integral. 1 to 2 root 4 plus x to the 6 plus 2x to the 4 plus x squared dx. There's no further way to simplify this, and so we're just going to plug it into an integral calculator, and you get an answer of roughly 2.84218, and that's going to be our final answer. Okay. Next up, we're going to be evaluating this integral over here. So we have the integral of sine x cos x dx. I need to remember the identity of 2 sine x cos x is equal to sine 2x. And so we're just going to divide both sides by 2 to get sine x cos x is equal to sine 2x over 2. And so now instead of using this, we are going to use this because they're equal and it's easier to find the integral of this. And so let's just rewrite all of that. And I'm just going to pull the 1 over 2 out. And next up, we're going to use substitution in order to find what we need to find. And so if we set u is equal to 2x, then du over dx is of course equal to 2, which means dx is equal to du over 2. Let's plug everything back into our equation. So 1 over 2 sine 2x du over 2. We're just going to pull out this 1 over 2 again to there. So 1 over 4, the integral of sine u du. And we know that dy over dx, sorry, dy over du, if y is equal to cos u, is equal to negative sine u. But now we want positive sine u, so we're going to have negative cos u here in order to get positive sine u, which means that our answer is going to be 1 over 4 negative cos u plus c. Let's plug back in what u is actually in x values, and that's going to become negative 1 over 4 cos 2x plus c. And this is our final answer. Don't forget about the plus c, because we don't have bounds here, so it's super important to include it because we have a whole family of constants that we could have deleted when we took the derivative. Okay, for our next question, we shall be finding the integral of secant x. This one is a bit complicated, but we're just going to be multiplying it by 1 actually. And so same thing as sec x times 1 dx. But our 1 is going to be equal to sec x plus tan x over, of course, sec x plus tan x. And so let's plug that in. And so and then let's simplify it by multiplying it out. And next we're actually going to use substitution to simplify this. So we just need to keep in mind that this is equal to this. And so let's choose u is equal to sec x plus tan x, which means that du over dx is equal to squared x plus tan. So this means dx is equal to du over sec squared x plus secant x tan x. And so now let's plug all of that back into our equation. And we get the integral tan x over u, and then of course put in the dx that we've calculated here. Sorry, just one moment. Sorry about that. These two cancel out, of course. And so let's just write it up here. We get the integral of 1 over u du. And this we know how to find, and it's going to give us, of course, the magnitude of u plus c. And so let's just plug in what u is, and it becomes ln the magnitude of secant x plus tan x plus c. And this becomes our final answer. Okay, on to our next question, and we're going to be looking for the derivative of cotangent squared, and we're just going to use substitution. And so we want dy over dx if y is equal to cotangent squared, and we're just going to rewrite it as y is equal to u squared if u is equal to cotangent of x. And so of course we're going to use the chain rule, so dy over dx is equal to dy over du, du over dx, and then they cancel. And so dy over du, we're going to use the exponent rule, and that just states that dx to the power of a over dx is equal to ax a minus 1. And so this becomes Sorry, just one moment. Sorry about that again. Okay, so du over du is of course 2u multiplied by du over dx. And so we know that du over dx, so the derivative of cotangent, is going to give us cosecant squared. Sorry, negative cosecant squared x. And so now let's just plug in everything, and we're just going to put back in what u actually is, which is cotangent. And so we get 2 by cotangent x times negative cosecant squared x. So negative 2 cotangent x cosecant squared x. And this is our final answer. Okay, this is going to be our last question. And we want to evaluate the indefinite integral as an infinite series. Okay, and so we're going to need to find arctan x squared in terms of an infinite series. Okay, and so we already know that arctan x is equal to the series, so the summation from n is equal to 0 to infinity of negative 1 n x to the power of 2n plus 1 over 2n plus 1 as long as the magnitude of x is less than 1. Okay, and so this is going to mean that arctan of x squared, so x to the power of 2, so we're just going to multiply this by 2. So n is equal to 0 to infinity, negative 1 to the power of n, x to the power of 4n plus 2 over 2n plus 1. And so when we want to find the integral of arctan x squared, we can also, so the integral of arctan x squared is equal to the integral of this. These terms have no x value, so we're just going to pull them right out, so that it becomes n is equal to 0 to infinity, negative 1 to the power of n, and then the integral of x, 4n plus 2 over 2n plus 1. And so we know that the integral of a minus 1 is equal to x to the power of a. So we're going to use a similar methodology here, and this becomes, dx. N is equal to 0 to infinity of -1 to the power of n, x to the power of 4n plus 3 over 2n plus 1, 4n plus 3. And if you just want to double check, you'd be subtracting 1 from here and bringing it down. So a is 4n plus 3, and then it would cancel with this one, leaving 4n plus 2, which is what we have up here. Okay, I hope you all enjoyed today's class. If you need any extra help, it should be in the description. Be sure to check out the OneClass channel and the OneClass page if you're looking for extra help at school. Hope you all have a great day.